Good morning, this is your stats sensei, Mr. Spensey, and we're looking at a 2018 question number 5. So the following histogram summarize the teaching year for the teachers at two high schools, A and B. Teaching year is recorded as an integer with the first year teacher recorded as 1, second year is 2, and so on and so forth. Both sets of data have a mean teaching year of 8.2. So 8.2 in this one and 8.2 is our mean, with data recorded from the 200 teachers at high school A and 221 at high school B. So we have 200 here and we have 221 there. On the histograms, each interval represents integer values from the left endpoint up to, but not including the right. So this would be 1 to 3.99 years, 4 to 6.99 years. All right. So the median teaching year for one high school is 6, and the median teaching year for the other high school is 7. Identify which high school has each median and justify your answer. So the median for high school A occurs between 201 and 200, and divided by 2 equals 100.5. We have 200 students or 200 teachers, and so we add 1 to it. And so we end up with 100.5. All right. So when I look at this, and they didn't number this, but 46 and 48, that doesn't get me high enough. All right. But when I add 24 to it, I get there, because 46 plus 48 doesn't get me to that 100.5, but I add 24 and I get to 118, which is over. So I know that in bin 7 to 10, then I know that that is where my median occurs. Well, if that's the case, then this must be 7. All right. The median for high school B occurs at 222. Once again, we have 221. We add 1 to it and divide by 2, and we get 111. And 79 is not enough, but 79 plus 34 is over that value because we needed to be over 111 and we get to 113. We need to be over 111, we got to 113. So that occurs in the 4 to 7 bin, which means it must be 6, has a median of 6. So therefore, the median of high school A is 7 and the median for high school B is 6. So to get my points, I needed to have this correct decision. I need to have some explanation as to how to do that. And I needed to define the median. So I can either write the median as the middle number from least to greatest. I also know that this takes care of it because the median is the middle number, and 201 divided by 2 gives me the median. So, and 222 divided by 2 gives me the median. If you had used 200 and 221, technically not correct, but they would have still given you credit for that. All right, what you have to show, you had to define the median or show that the median was used, and there's the numerical definition of the median. And it might have been easier just to have written out the middle number from least to greatest. An additional 18 teachers were not included with the data from the 200 teachers at high school A. The mean teaching year of the 18 teachers is 2.5. So what is the mean teaching for all of the 218 teachers? So first off, we have 218. That's the 200 plus the 18 is 218. Didn't need to show that, but that's what we have. Well, how many years did the 200 have? Well, 8.2 times 200 tells me that we had 1,640 years total. The new teachers, or the teachers that have been left out, will be the 2.5 times 18. And they had a total of 45. We add those two together and divide by 218, and we end up getting 7.7293. You had to have the correct work, then you had the correct answer, and the work, if you had both of those, you got an E. Small error would get you a P. All right. If you don't show your work, you could actually get a P, believe it or not, which is kind of amazing. So part C, The standard deviation of the teaching year for 221 years at 221 teachers at high school B is 7.2. If one teacher is selected at random from high school B, what is the probability that the teaching year for the selected teacher will be within one standard deviation of the mean? All right, so they tell us here that we have a standard deviation of 7.2, and up here in the problem, they said that they had a mean of 8.2. So 8.2 plus or minus 7.2 is 1 to 15.4. All right, 8.2 minus 7.2 is 1. 8.2 plus 7.2 is 15.4. So if I'm looking at on the graph, I'm like, okay, we're looking from 1 to here. So if I add that up, that's 79 plus 34 plus 28 plus 29 plus 18. All right. And they want to know what's the probability that the teaching year for the selected teacher will be within one standard deviation. Well, that's out of 221. So 79 plus 34 plus 28 plus 29 plus 18 divided by 2221. The scoring guidelines said I should have used 19. They're not going to count that against you if you had that error. So I end up with 0.8506. And once again, these numbers came from the 79 teachers that had 0 to 4, the 34 from 4 to 7, the 28 to 7 to 10, because this is the plus or minus that we calculated in the lower part. All right. I hope that helps and look forward to seeing you on the next one.